So the last talk for today will be given by Elena. And of course, the second name, maybe probably have some questions. It's coincidence, not really, be a couple. And of course, the question is always, whether I have a conflict of interest or like I'm just using, opportunity to show my wife to the rest or, to kind of things. But the truth is that if choosing between two of us standing over here, it's more likely that I should not be around, but Elena should be. And the reason is that over last 5 years approximately, I think you were part of 10 plus European projects. You have a platform which is used by quite a lot of people, and companies over Europe. And then also recently also in the advisory board for HPC, quantum, and so on. So I think that it would be a crime not to give you a chance to talk to this community. And having said that, the stage is yours.
Thank you very much. So my topic on sustainability is very different because it's actually about it is about services, operationalization of the services. Should work. But for a specific domain, which I want to concentrate upon today, and that is sustainable transport. So there is right now the ZeroNet initiative where there is a push to go to the electricity transport, and not only for the personal cars, but also for logistics sector, so to transport goods. And that is, my topic is today, how would you operationalize all possible services from all companies surrounding logistics to one overall, let's say, platform and one big service to serve the logistics market. I'm working at TNO. For those who don't know TNO, it's Applied Research Organization of the Netherlands. So that means it's similar to Fraunhofer, INRIA, CNR, and other agencies like that. So it's applied research. We have around 5,000 people, around I think 60 professors, more or less part-time professors at the universities. And since we are between academia and industry, that is why we yearly have around launching new 3,000 public-private partnerships for different topics. And we are also active in Horizon projects acquisition. So typically for TNO, it's around launch every year around 60 projects. But remember, it's 5,000 people, and all the units, it's under one umbrella. So some projects are in energy, some in industry, some in health and work. And I myself, as you can imagine, in ICT strategy and policy unit, which is around 700 people, and from ICT side, obviously. So, and just more introduction of myself. So I have two backgrounds. I started with law, and that was cooperative law. So that teach me diplomacy, that teach me contracts, that teach me understanding the legal constraints. And then I switched to computing science. It's a long story, so I will not talk about that. In computing science, my specialization is in distributed systems and software architectures, and that is where I work for more than, I think, already almost 20 years. And I'm a senior scientist at the department which is called Advanced Computing Engineering. It's around now 45 people, and where we push computing further to its borders, where we push on distributed platforms, and I specialize a lot on digital twins as a good domain of applications for the distributed computing and distributed platforms. So I'm also part of the FAIR Global Architecture Group. So if you have heard of FAIR data, I'm not about FAIR data, I'm about FAIR workflows, and I will talk about that today. And since recently, I'm also Dutch advisor to the Research and Innovation Agency of joint undertaking of EuroHPC, quantum, clouds, and AI factories, where I'm on my individual capacity as an expert provide my opinion on the topics and setting up agenda for the future of computing. So these are different types of projects that I was performing in the last years. What is common in them? Actually, it's a lot about physical infrastructures, somehow, but not only. It's also a lot about data. It's a lot about different models. But first of all, it's about different parties which create data sets, who own data sets, and who own models, and they're typically diverse. So to have a solution, you need to combine the knowledge and the models of third parties, and you need to provision data in a secure way to make the services work. So for now, of course, it will be too much to concentrate on all of them, so I will concentrate on this part, on the sustainable transport. So what are the problems in electrical vehicle logistics market right now? So actually, customers need to know how I put it, like this. Customers need the right electrical vehicles. So there are different configurations, there are different producers of the vehicles, and they produce different configurations of electrical trucks. The question is, as logistic party, you ask yourself, which configuration do I need for my fleet if I want to buy a new one? So there's a question of investments. Second is, customers need smart charging, and trucks charging differs from personal car, especially if we talk about long-haul trucks, as we have in the FEV project, then the charging will be much more complicated. And the third part of the concerns of the logistic market is customers need to know how to effectively plan, schedule, and guarantee that their transport comes to the destination on time. So surrounding that, we have quite some European and national projects. So the first question we try to answer with Horizon Europe ZEFIS project, 41 partner. We have the OEMs like Volvo, Renault, Ford, whom I've forgotten, Scania. And we have logistic parties. And actually, this project is dedicated to allow in Europe less amount of trucks, but bigger trucks, longer trucks. So, and to prove that it is feasible. Such trucks are now allowed in Scandinavia only. Europe doesn't allow it without first check. Is it possible to have such long trucks with 2 trailers, 3 trailers in mountains? Is it possible to bring them to ferries, through rivers? So there is an assessment of 4,000 kilometers of the driving of the long-haul trucks through different countries of Europe to check how does it happen. Of course, there is a digital part to it. There are many tools being created for digital twins from different parties. Michelin, for example, does it for the tires. Bosch does it for energy infrastructure. Companies which surround, like ABB or Ricardo, which surround trucks, they do digital twins for the trucks. Other experts do it for battery management. Huge amount of the tools needed huge amount of data. So the second one, there we go to edge, because there is a charging infrastructure added. And that charging infrastructure, of course, there is a lack of now of charging infrastructure, especially again if you talk about trucks. And nobody knows how it would work perfectly between personal cars and, for example, so big trucks. Who receives priority, why? And here the big question also is, can I book my slot before I come? Can I guarantee that I can charge if I come to your location? Do you have enough capacity? So there are tools built for that in these projects. And one project which starts, it's about adoption for smaller logistic companies to make really the work as a service, to connect directly to the software of logistic parties of all possible tools. So, big problem here, as I told, huge amount of tools on different levels. You have digital twins of components, you have digital twins of vehicles with all auxiliaries, you have operational charging infrastructure tooling, and you have fleet management layer. They all make the decisions. However, the decisions influence the other digital twins. So we need the mechanisms of coordinations. And that is what our role is. So we are making platform and coordination mechanisms which combine it all as a service to answer that big questions of the logistic industry. We have, from that perspective, data providers, edge devices, obviously, from trucks, from energy infrastructure, and data loggers from the trucks. Simplified, very simplified version, and then I go to details, is this. So you need to have a platform. You see it here centralized. It should be distributed because it should be scalable enough to support all tools and all different types of data. So, which needs to take data in of all the different devices with different frequencies, with different models, good luck, to make one representation of the data from that for the usage of analytic tools. And then you need to have a data storage layer, which would allow to save the data from images till sensor data, or make some videos. You should have metadata layer above, which is responsible mostly for the description of the data. So what do we have? What is the structure of the data sets that we have? But metadata is not only about data, but it's also about models, because it should describe which models are used, which services are used, what is the functionality of the services, etc., etc. Above that, there is an analytics layer, so that is where digital twins live, where all tools live. And I want to mention that our problem is more complex, practically, because not all tools are given to us to run by us. Some run on their premises. So we need to make something that would connect through APIs in right moment, make it to be able to make call to the premises, provide right input, receive output, and continue. And there is visualization layer, and that is obviously for different users, for different tools, it looks different. So I feel we are zookeepers that need to combine all the animals into one place. This is more complicated picture of the architecture. So, because we do separate, and here I go a bit to technical details. What I told about, for example, data gathering, I already told that very different data, very different frequency, very different tools. So you need to make good ontology kind of to represent everything in one representation. But on data storage, it's also the question what we learned from practical view. It's very important to separate raw data from process data, because every modeler loves to make own view of data, to choose subsets, to tweak, to filter, but you wouldn't allow to change your raw data. So your raw data, it's unchangeable, nobody should touch it, it's a single point of truth. That's your goal. However, there is a process data, and that process data that is the result of workflows running on the system of all models, but also the result of the specific tools, which also companies want to sell, to save for themselves. Views on data, that is for modelers, for the experts, to save for pre-training, for training specific subsets of data. It's important again to separate them because of the security and isolation properties. Because companies would not love another company to see their data, but they would allow, for example, specific expert from specific organization to see data. So we need to make a separation because there are different handling mechanisms for security there. Metadata is more open. Metadata layer, it's about all metadata, about what vehicles are. So there are two parts of metadata. Organizational, kind of, this company owns that trucks are from Volvo, and this has that and that sensors. Another part is for traceability, and that is to trace every operation, every workflow run instance, which was done by platform, on platform, by the users. Above that, that's where the tooling lives, and that is where we need to create workflows. Because the problem is, right now, almost no tool can work by itself. They need information from other tools. So you need to create workflows with sometimes 3 models, sometimes hundreds of models from different experts to really reach the decision on specific question taken. And the last one, again, that's visualization. I will not touch that a lot. And of course, there are the pillars which are very important for the platform. If you want to make it really work, of course, authentication of authorization is a big part of it. Actually, when we agreed to participate and to make the platform, we thought, oh, security, it's a byproduct. It's kind of okay. Needed, we will make something. But in the end, this is the main feature, actually, of the platforms that we have. Because if you have many actors with different goals, if you have competitors which do not allow each other to see the data, you need a very clear authorization mechanisms and security mechanism which allow you to handle the complexity. So what we did, we literally needed to promise that we provide the decisions on security to the for example, on data owner. So if data owner, you own the data, you decide who will see your data, not us, not who have the platform. And only then they were okay to share data. Because before that it was no, we don't. So then of course you need orchestration between different digital twins. You need registry for models, obviously, and monitoring and logging. I cannot touch everything, so if you're interested in practical details of every block, I can talk a lot about it, but I needed to choose. I don't have a lot of time. I also don't go to H today, again, because of the lack of time, maybe next time. However, I will touch today identity, access and management, because it's important part, data ingestion part, and traceable workflows. So, access control. What I already told. If you have companies like Volvo and Scania, they say no. Volvo says no, Scania cannot see our data at all. So you need to have authorization mechanism. Who is who? However, so that is how it looks on our platform. However, this is a problem that sometimes user starts the interaction with, for example, models, but user starts with the workflow, so it becomes an application for data. So you need both and user token to understand who user is, and to understand is a trusted application right now which has access to that data set. So we need two types of tokens. We need a user token to understand who user is, and kind of machine token for the session of user, which would provide us details. Okay, that in that session you are allowed to touch that and that models, and that data sets, but as an application to application. What do we do? What do we use? We use actually Zanzibar model from Google. It's a pretty good one. As a permission model, because it's kind of triple, very flexible, easy to manage. That's subject, person, organization, has some relation with the object. And that is how we implement it. It's scalable, it's easy to implement. So there are some open source tools, pretty known, which we use for to have permission models work. So we have Orchestration, which is digital identity manager. So that says who users are. So if user is Mark, then it says Marco is from Stuttgart University and has rights to that and that datasets, for example. Authentication server, it issues secure tokens for users and for applications. And SpiceDB, it saves all relationships, so like your rights as a user, be it organization or be it person. So if you are typically what we expect, you are a member of some organization that you want, that's why you want to access some data to run it. So user is Mark, is a member of group TNO, and group TNO, for example, can view that dataset. So that means if Mark is in that group, automatically there is a relationship that he can see that file, because he's part of the group. So I will not go into details here. I'll just tell that we have made a very modular system, because sometimes you want to change some parts. So ideally is to have it as plugins. So literally we have made for every, I would say, layer of the systems that you have seen, for workflows, for storage, for visualizations, we have made plugins which always contain which actions could be performed. For example, for file you see here, you can download file, you can upload file, you can create bucket, so kind of folder which contains more files, you can delete bucket or share bucket. And the share bucket, if you are owner, you can decide to share it with somebody else. Then, for that actions, there is a stored permission model, which defines who can do what and on which extent. And then there is a backend, because the problem with the ZOO that every tool has its own security mechanism. Let's not forget that. So we need to combine the security mechanism which exists in every tool with that permission model. So and here we made combination for data management with the security mechanism of Minio and Ceph, that is for file storage, and for Apache Cassandra for time series data. In the end, we needed to create API. So API for us right now is the central point through which you can talk with all the tools and all the data in platform. Because you need some controllers that can make permission checks. There should be some point. So you can see it is centralized, but its implementation is distributed. Again, I will, if you're interested, I can talk about how to implement it distributedly. However, so this is every user first connects to the API to check when there is an authentication to the platform. Then user can start workflows, some tools, some models. And then the same API will check, so in the beginning of workflow, does that user has access actually to all the models, and does the user has access to all the chosen datasets from other companies. And only then it would start. If not, if it's not successful, it would say, well, you need to arrange first the permission to see that file or that model, for example. So in the end, as I said, we have core plugin, which is kind of API, and we have kind of matrix, so there is API. And for every file storage workflow metadata plugin, we have user and group actions. We have control permission models, written relationships, and the combination with the backends. That allows us to have modular system, which allows to have many different backends. Because if you just need to add backend, you just change a bit that combination. You don't touch permission model, for example. So we can have many different backends. We can run securely our Delight platform functionality, and it also, thanks to the machine tokens sharing with the partners, we can also talk machine to machine with the partners which have services on their side. And above we have applications. Now I want to move to data flow, and just want to present you to have an idea how actually secure data flow could look like practically. So imagine that there are the trucks on the road, and they send signals. From every truck, right now we receive, I think every millisecond, there are around 60 or 70 signals, depends on the model. So they are coming within truck to the so-called canvas device. So our partner Fraunhofer in this project, they have created so-called sniffer device, physical, certified, which can take the signals from canvas bus, but filter it. Filter it because still OEMs don't allow you to see all signals. So there is always long negotiation about which data can be made available. However, so it can filter devices and can put it into some temporary database of them. So they have security protocols that guarantee that it's not hackable. But after that, the security is on us. So literally, we need to take it from Fraunhofer periodically. Literally, actually, we do it every hour. We run our engine. Then our data scooper checks, so is there new data, checks other files are complete, not corrupted, can we download them? If not, it provides some warning. If they are good, then the files are taken into the platform. Before adding that to write it to the actual database, in this case it's representative as Minio, it writes on metadata facilities that I have added for that file new data, because metadata contains biased also the last value, so what is the period of the data that we have for the specific data set. When it writes to metadata facility and also to Minio, it should connect this API, security API, because it's a writer, it's an application. So to access Minio, it should connect the API, which connects token manager and SpiceDB to check, do you have rights to write actually data to that bucket. For example, if you will want to write to Scania bucket, you shouldn't be allowed, right? So, and only after that, you would write it into the database with all checks performed. So here there are some examples. What I explained, there is a download client, upload client. So when we check the integrity of the data sets, and there is a part of the downloaded finally, and that all shares that token of the client and machine-to-machine token of the application. So metadata. Metadata is connected to data, but not only to data. I have told you it's connected to the models as well. Because actually, if you have many companies, like 41 partners in the office, and they have all different data sets, you completely lose overview which data do you have for which periods, which attributes, which sensors are where, etc., etc. So you should be able to find it easily and to understand where is the data that you need for your purposes, for the modeling. So we need to understand also for data where it comes from which tracks, for example. If it's processed data, with which steps the data was made, right? And also we need to save workflows, literally. Not the instances running of workflows, but the descriptions of workflows, actually, which allow us to understand, okay, this is a workflow with which the specific data set was created. So it's findability and traceability. Because, for example, ZFS, on which I concentrate now, it was done for assessment purposes. That's why we also couldn't use foundation models and AI agents. They were not accurate enough and not reproducible in terms of that it could provide guarantee that it's really that long-haul trucks can run on our roads. No. So that's why you don't see agents actually in this specific project. So, of course, typically there are the standards and ontologies for specific data sets. The problem is they're not always full, not complete. So, for example, COVESA, which was discussed and was agreed upon as consortium standardization for the signal representation of data and vehicles representation, that standard was made for personal cars. It was not made for trucks. And we needed to extend it to make completely reproducible, let's say, representation of the actual trucks. So we needed to extend that one, and we needed actually to extend it. We use OrientDB graph for saving all the relationships. We needed to extend it also with the links to the specific data sets descriptions, which contain the specific subsets of specific signals. So we don't stop on signals, we also save in metadata the links to the structure of the data sets which are presented to the system. So it was second extension that we needed to do. And that should be done if you make common data representation for the whole sector. And that is how it looks like in the end. And this is, there are two accounts, different accounts, and there is a data management page. So it's simple for user. You can have view rights. View rights only allow you to see structure of the data, so that is only metadata. You have rights on the view content, so that means actual data. You have access to actual data, and you can, or you are owner, so you can do whatever you want. And only owner can allow the new people to see the data. So you would see that it's two different accounts have different rights. However, intrinsic complexity, which is not easy, which is not seen by user, there is a lot that you should do to guarantee that, or really to guarantee the security. So my message is always there is hidden complexity there. And the last one part that is fair workflows, because I told that a lot of work in descriptions of workflows is done on fair by fair association is done on fair data. But the models, they also require attention. Because in the end, this is the traceability suggestion for the new standard for the traceability of the fair workloads. What you will need to keep if you want to have good, stable description of the workflow and tool data. So you need to have some asset nodes with some properties. It's actually a sensor or some device to understand where data comes from. So you need to have notion of that. Then, of course, you need to have a notion of how data comes from that asset, right? So which frequency, which format, how often, etc., etc. Or description of the database from which it comes from. Because if you want to request some data and that is SQL, that would differ from NoSQL databases. And then it all comes to the notion of the input data. So you need to make not only the nodes, but also relationships between these objects to trace in your system. So input data, that is the raw data which is needed for the workflow. Then, of course, we go to the models description, and that is you want to have as well, because you also need to trace, to have description of the model, but also to trace the history of the model, different versions, changes of parameters, configuration, hardware parameters, and all other stuff. And then you need to describe the workflow itself, so how it looks like, which model is after which model, and you need to keep it again in trace, because different workflows could use even different versions of the same model. So you need to keep for every instance the trace, which exactly version of which model was used, which exactly subset of input data was used, for which time period, etc., etc. And of course you have output data, so process data, and that is the resulting data. And what we understood is very useful to create direct link between process data and input data. And that is because many users, for reproducibility purposes, ask, okay, I have now result, from which data it was created. So this is discussed by workflow community experts, and it's actually agreed convention. That's how workflows traceability for instances of every workflow should look like. So that was a presenting a workflow community summit. But the workflows are not about only metadata about workflows, they are running. And you have two parts for workflows on, let's say, regarding as a workflow to computing platforms and as a workflow as part of application. So this one is the work about trying to make the classes categorize the workflows on different types and how they would run on computing. What is the need of different type of workflow to connect it to specific setup of computing. So I say we go further than that now. I'll just make a hook maybe for the next year, because we now have a work which we try to make a criteria for the applications, for the automatic choices of the most suitable infrastructure. But we go beyond cloud and edge. I did a program on that at TNO. We also look into what is the difference, which type of application is better for HPC, for quantum, for neuromorphic, for photonics, so also alternative types of computing. But this is a hook for the next year. I'll just tell that this is complicated because even experts themselves cannot express very well where they're good at. So we try to do it. But now I just want to concentrate on the last couple of minutes on the categorization of the workflows from the application side. So you would say that there are different classes of workflows and they will require different handling. Let me start actually not with sequential workflow, but with parallel workflows, where you have one start, then you have independent tasks, independent applications, and then you just gather the results. Easy to handle. You just make a start point, you run all of them, and you have only one central point to merge them. That is from the service platform perspective. But sequential workflows, they are a bit different. You need to have an order between the different models. So Kubernetes, for example, will be not enough because it's just low level and it doesn't guarantee you order. So you would need some workflow engines above Kubernetes, which can start for you automatically all the models, but it doesn't have an order. So you need workflow engines. However, much more problematic are conditional and iterative workflows. Because conditional is, okay, we run in one model, then some condition happens, and then you should make decision, do we proceed or not? Or for example, if parameters like that use that model, or if parameters like this use another model. So that already requires some composable workflows. And the worst of them are iterative workflows, and many of them are probabilistic workflows. Imagine that every model can converge or not converge, And then because of that, you would decide, should you retry, should you repeat the model, or should you stop sometimes and make it unsuccessful. But then when you can do the last model. So that is my timer. This is literally the last slide. So I'm practically on time, and that is the example of the Bayesian representation of the reaction of the iterative workflow. This is a probabilistic workflow. So from the service platform perspective, you should have monitoring workflow which would check every model of this composable workflow every time for convergence, not convergence, and you should have policies of retry, refine, fallback for every type of model. So only if you have them automatic, you can then run automatically workflow of such a nature. So these are a couple of screenshots. Again, that is what user sees. Okay, we want to make the most optimal route for logistic company, to plan the most optimal route for the specific configuration of the truck to reach specific destination. So you could have your configuration put into the, you provide some description of the start point and destination. There you would have a button run workflow, you click. However, and you receive your result. However, what happens inside, there are 3 models involved, also about roads, about the roundabouts, for example, problematic points for the long-haul trucks, and also probabilistic calculations on energy provision. And so it's again, it's hidden complexity from user. But what should be done to support it, you have just seen. It's iterative workflows that we need to support. So here there are some let's say, references to this work. And I would say that for the next time, I will save the H part with the online optimization agents, which should be very sustainable and very efficient. For now, thank you for attention and questions.
Thank you for a nice talk. So maybe it's obvious, but I was a little bit lost.
Yeah.
So you have all this nice architecture, you can talk, you have the tokens, but do you really have interoperability? I mean, you have so many different players. Do they well behave, and then they can really work with each other?
So of course, with every player, we needed to make it API to API test, and to really make special listeners and API for the agents. So they need. Every time it was a discussion about what should be API on their side, what should be API on our side, and we needed to implement the loop of the interaction with the security protocols with every provider. That is extra work, yeah. But it should be done, otherwise it wouldn't work.
And then another question is much more open-ended. So Aurora is having trucks driving autonomously from Dallas, I think, to Austin. How long will it take for us to have the same in Europe?
Well, I have participated also in the autonomous cars and autonomous ships programs. There are the models, there are already the blocks under development for planning the routes and for platooning, but it's still fragmented work. I feel that specifically what is underdeveloped is safety blocks. So safety for people, safety for people, for drivers, let's say, but also for people inside the cars. They're still, now it's a hot research topic because they're underdeveloped. Where it was good is maneuvering between the different drivers line. It's good in planning the trips. I think you have seen it.
What about the redundancy of the platform? That's another thing. So if something fails, you have to have a secondary.
Yeah, so the failed backs, let's say, mostly. Yeah, I have another talk about self-learning and self-optimization, but that's a different talk maybe for future. However, for energy efficiency, for, let's say, no, for the fuel consumption and good planning of the trip, they are done, also with the fallbacks. They're always done only for worst case, not for the average case, and that is to ensure more safety. But again, safety components are not done, and the kind of comfortability parameters of the people inside the car are not taken into consideration yet. mostly, to be honest, because of GDPR. So GDPR is a big obstacle to make that research.
Yeah, thank you for the nice talk. A totally different question. As far as I understood, you build a multi-purpose platform.
Exactly, for any application.
Is this somehow data sovereign?
Yes, it's definitely data sovereign because it doesn't run in cloud, it runs on our premises, because we are trusted as TNO, as a non-profit organization in applied research, so everything runs on our services, but we make everything portable, every component, so it could be easily put in any infrastructure which is needed. However, it's European part, yes.
And you only need open source tools.
Yes, so right
Okay.
now we are busy with the open sourcing the platform, so in 3 months the first release should come actually.
Mhm.
Unfortunately it didn't come, I hope, before this conference, but it will come in 3 months. Yes.
Thank you.
Also from my side, thank you very much. At the end, you were talking about different workflow structures
Yes.
and concepts. Did I get it correctly that you invented a proprietary workflow language, or did you use some well-established one?
Now it's not no, we used first Argos and we changed to temporal workflow engines because they were flexible. We were not satisfied with Argos, so there were known tools, and that work with Docker containers because we request every tool to be containerized, otherwise it becomes not possible to combine different models written in different programming languages without containerization. However, again, for some specific parts, for some producers of the data of modelers, especially when the service runs on their premises, we need to add different solutions. So part of it is not common, but the common part is actually, we like now to use temporal, that's the name, temporal workflows, because they have, it seems, the most flexible for now from open source community.
Thank you.
And I would say then thank you to the speaker. And with this we conclude our afternoon session, but not fully, because we still have a coffee break or a poster session, depends on how you would like to look at it. But maybe like whatever you are motivated with, more science or more drinks. But that would happen just around the corner, and I think that session starts in about 5 minutes. So
Where?
oh,
Coffee's there already.
so coffee is there, so we start anytime. So please